So you've got the solar that's generating during the day. It's providing energy onto our grid during the day, but at the same time, it's also charging the batteries. So you've got the energy going two directions. Then the question is, well, who owns the energy that's charging the batteries? Do they have to pay us for that energy? Because we're paying them to provide this solar facility. So are they taking that energy from us to charge their batteries during the day? So there's been all of these questions that have come up that have complicated it.
Dynamic Ratings partners with utilities to successfully implement integrated asset monitoring solutions that reduce unexpected outages, improve reliability, extend asset lifespan, and deliver measurable results. I've got Carol Griego with Public Service New Mexico, PNM, a large investor-owned utility in New Mexico. Carol, you're the manager of a department that handles telecommunications, SCADA, and all things around the complexity of integrating renewables. You've been telling me a little bit about this. We've met at IEEE, and you started telling me the complexities of the challenges you're facing to integrate renewables. I'm so fascinated to hear your story and for our audience to get to know you and to get to know some of the challenges that utilities will be facing, considering, as I understand it, Public Service New Mexico is really leading the industry in the United States with the adoption of renewables at about 80% now. Is that right?
Right. Yeah, we're at about 80% renewable between wind, solar, and battery.
Which is remarkable. It's a story that needs to be told because I haven't heard that. And then the fact that you're going to be able to give us that view of what is it like to integrate that is amazing. So first of all, go back a little ways and tell us, how did you get to be the manager in the middle of all this complexity? Give us a little history and how you got your start in the industry.
Well, I graduated from UNM and I worked for some architectural engineering firms, and one of them was doing consulting, contracting work to Sandia National Labs when they were upgrading their 2400 volt system to a 12.47 kV distribution system. And so I got familiar with distribution there. And that helped me get into PNM when I applied for the new service delivery sector of the company. Now it's part of distribution engineering. And basically what I was doing at Sandia, it was the same thing we typically do over new service delivery to get customers connected, commercial grade customers. And then from there, I ended up in project management for a while, and I was working with the substation department. And I asked for a rotation into system engineering. And so from that rotation, I got to do 3 months with stations and 3 months with controls. And I really enjoyed the controls.
Right? I mean, they're really able to move you around and get a broad background in all that is required to deliver this amazing essential service that we have, our electric services. So what did you go from there?
Well, after the rotation, they opened up a position in the controls and SCADA and controls group. And so I applied for that.
Okay.
And that's where I landed. And I felt like I finally found my home when I came to this department.
Okay. About how long ago was that you started in the SCADA and controls group?
16 years. And I've been with PNM since literally right before Y2K, like December 28th of 99. So I've been here a long time. So
the SCADA and controls is really that deep expertise that you're bringing to this team. And obviously you're managing the team now. But so then you worked your way up through that organization and eventually applied for the manager's role. Is that right? Right.
Our manager moved to a different role. And so that left an opening. And so I applied because, I felt it was better that we get someone internally promoted up as opposed to bringing someone from external to the company that isn't familiar with how we do things or our standards, that sort of thing. Yeah.
So now what does the group entail? It's entailed a lot more than just SCADA and controls, right?
Right. And used to metering was kind of a subset of SCADA and controls, but because these large interconnectors on the transmission system, require so much more complex metering, we've had to kind of separate metering out a little bit. And we currently have an opening for a metering engineer. So I don't technically
Good
have
to
that
know.
position filled at the moment, so a little plug
Hmm.
there for anybody. But I'm borrowing an engineer from our protection group that has really gone in and dug in and figured out all of the ins and outs of the requirements, from codes to regulatory requirements, that sort of thing. Cal ISO, we're all tied into that. So there's a lot of requirements for metering revolved around the Cal ISO connections. So for us to be publicly traded on the Cal ISO market, we have to be fully redundant. So the interpretation that PNM has taken of that redundancy is that not only do we have to have 2 meters, because before that was all we did. We'd have 2 meters and we were considered, we got redundant metering, right? But we've taken that a step further to where we have to have redundant SCADA, we have to have redundant COM paths. So we are 100% redundant from that perspective. Now, on the interconnector side, we're even asking them to provide dual redundant CTs and VTs and that sort of thing. So if we're reading their meter data and bringing it up into our meters, all of that has to be dual redundant. And on our side, we have a metering panel with a couple of ION 8650A meters. I don't know if I can plug the manufacturers, but that's what we're using.
Oh, you're welcome to mention manufacturers. In fact, that's the way we prefer it. If something's
Okay.
working, there's no sense in keeping it a secret.
Right.
For someone who's a novice in the area of metering, walk us through the importance of metering. So it's my understanding that someone once described to me the power pool, if you will, of energy is a very shallow lake. And there's water coming into the lake at the same rate the water is leaving the lake. There's no real significant storage. Now, of course, we have some battery storage and maybe some hydro storage someplace, but by and large, it's something that's made and used almost instantaneously. And you have meters that are metering how much water is flowing into the lake and how much is flowing out of the lake. Is that a reasonable analogy? And help put some meat on the bones of that analogy, or
Right.
correct it if it's wrong.
That's a pretty good analogy. But what we're seeing with interconnectors, especially once we add BESS, is that the batteries. So you've got the solar that's generating during the day. It's providing energy onto our grid during the day, but at the same time, it's also charging the batteries. So you've got the energy going 2 directions. So then the question is, well, who owns the energy that's charging the batteries? Do they have to pay us for that energy because we're paying them to provide this solar facility? So are they taking that energy from us to supply their batteries, to charge their batteries during the day? So there's been all of these questions that have come up that have complicated it. And then in the afternoon or the evenings when the batteries, the photovoltaic cells shut down for the day, they're not generating. There are loads associated with the equipment that's now drawing energy from our grid. So they have to, we're buying the energy during the day, but then in the evening, we're selling energy back to them to take care of their retail loads. So
Right.
like
So those
lighting, air
batteries, are they
conditioning.
always on site for the solar, or are they sometimes off site? Are they your batteries, their batteries? Is that where it gets confusing, or where does the confusion come in? I want to dig into
Well,
that a little bit.
a little bit of both. PNM owns some of the systems, but I would say we don't own most of it. And to make
Okay.
things even more complicated is some of the sites have multiple owners. So then
I see.
when you're taking care of the billing side of things, you're having to parse out that metering data by, okay, well, this company owns 20%, this company owns 40% of the energy that's being delivered to our system. PNM is using this
Wow.
much. And all the while, PNM is sending AGC set points like, okay, well, we need to increase your generation. We're having a peak right now, so we need you to up from 200 to 300 megawatts. Oh, wait, now load's gone down, so decrease that to 150. So all day long, this is happening. So not only is energy flowing, it is instantaneous. It's like constant.
Well, one of my questions is going to be, what are some of the challenges you're currently seeing? But I think we're hitting those head on here. That sounds very complex.
Yeah.
And where is all of the interconnection? And so I guess I have two questions. How does all this interconnection work? Do you own the fiber optic or whatever network you're using to pull that data back? Or is it wireless? Is it who owns those networks? Do you have to maintain them? Do you have to build them out? And then once you get the data, is it just in a standardized format and you can just use it directly? Or walk us through, at least, I'm sure it's not a one size fits all, but what are you dealing with in that space?
So we'll own our transmission station, right? And then someone else will own the interconnector station. And sometimes these stations share a fence line. Sometimes they come right up to each other, and that fence line will be our dividing point. Okay, this is our point of interconnection. We own this side of the fence. You own that side of the fence. And so for like the fiber optic communication, there'll be a splice box right outside our fence on their side, and they'll provide enough fiber to reach all the way to our patch panel, and then they'll just coil it up into that box, that handhole, and then we'll run a conduit from the handhole into our cable trough, and then from the trough into our house. And then we'll take ownership that way if it's underground. If it's overhead, well, the point of interconnection is generally a structure, an A-frame structure or something like that, which is typically right. It's either our A-frame or it's a pole right outside of our fence line will be our point of interconnect, our POI as we call it. And so we own and we maintain everything from that POI back to us, and then they're responsible for everything from the POI towards their facilities.
So,
and we do have microwave, so there is some wireless.
Oh, okay.
You asked about wireless. So we do have some microwave networks. We prefer to do dual redundant fiber for our primary and our backup networks, but in some remote locations, which, a lot of New Mexico is outside the city limits. So,
sure. Especially probably some of these solar sites, huh?
Yes. They do tend to like the rural areas to establish themselves. Yes. Land is cheaper there.
Right. So then when you get the data, is it all standardized information, or I assume it's digitized, right? It's not analog anymore. You've taken that CT and PT information, you've digitized it, you've got some type of a data point or maybe even a waveform, but where does that come in, and how do you manage all of that information?
The ion meters that we're using, we have at least 2 ion meters that are connected to our CTs and VTs on our system. So we have dual redundant CTs that we're using now. So we have one transmission line going over to an interconnector, 3-phase line, of course. And so we have 6 CTs. So we have dual redundant CTs on that transmission line. We don't have 2 sets of VTs. We'll have a VT with dual windings. So that way we get our redundant VTs coming back into the meters as well. Then, so one set of CTs and VTs goes to one meter, the other set goes to our secondary meter. So those 2 meters are bringing in the data that we're seeing at our side of the point of interconnection. The customer has all of their meters set up at all of their various meter points because, their solar array may have several different inverters, so they may have several different points where they're measuring data. So they have all of their redundant meters and their redundant CTs and VTs as well. And then their meters literally talk to our meters. So we have sometimes an extra set of ion meters. We do have like some little mini RTACs that we're using to transfer data back and forth if they don't want to use ion meters, if they're going to use like SEL 735s or something of that nature, then we'll use these little mini RTACs to do some data conversion. And then the ions, if I understand correctly, they use Modbus to communicate. So their meters talk to our meters, and then inside our meters, a whole lot of calculations and math happens there. The magic happens there, where they've set up a whole template as to how that data needs to come to us from the interconnector side, and then that's where they do the percentages and the parsing out of all the data and how it needs to be billed. And then we send that data back to our MV90 system, where they manage the billing side of it.
You have still some thermal plants on the system. Does your group also meter those, or it's just focused on the renewables?
We're mostly the construction side of things. So if it's generation that's been there for 30, 40 years, we're not very much involved unless they're making updates or improvements to the switchyard. Yeah.
I see.
Yeah.
So you're really focused on the build out of the new systems, which predominantly has been renewable systems.
Exactly. Yeah.
Am I wrong in saying that this is pretty well standard? There just happens to be a lot more components involved as far as metering. And because there's a lot more components, a lot more people involved, there's just a lot more, it's the same type of components, but a lot more of them and a lot more complexity because of the number of players. The distributed energy resources is just that. It's distributed not just by location, but also by ownership and also by variability, right? There needs to be a lot more communication about loading and availability, right?
Right. And, if it's just a solar site or just a wind site or just a battery storage facility, it's not as bad. It's fairly straightforward. Energy can flow one way or the other. It's not flowing both directions at the same time. When you combine the solar with the batteries, that's when it gets complicated, because they're charging while it's delivering. And so you've got energy going in all directions. So it's kind of like you're talking about your lake with water coming in and water coming out. It's like having a water hose with holes in it. The water's going every direction. So that may be a better way to describe it. Yeah.
Yeah, right. Yeah, well, that's definitely a complexity that we didn't have before, at least not to this extent, and not so distributed, as we've said. Well, that's fascinating. I do want to talk about some of the challenges, because you're in this place where you have more renewables than any other investor-owned utility in the United States. So a unique position. And from that vantage point, what are some of the things that we should be thinking about for the future? Is there some challenges now that you're here and it's functioning, you're getting the job done, and you've learned what you've learned? What should we be thinking about for the future about integrating renewables, and especially as it relates to your area of expertise in the SCADA, the control, and the metering?
We're standardizing, right? But our standards are very dynamic at this point still, because a lot of these redundancy requirements are new to us. So we've been developing these standards as we go. So like we have a project right now where one investor has a solar facility already. They are going to be adding more energy to that particular site, but then instead of building a separate transmission line to feed their next site, because they're 7 or 8 miles away from us, they're going to extend their transmission line down to their next site. So this just took our metering complication to a whole new level, because now our point of interconnection is still like 100 yards away from our station, but their facilities are 8 miles down the road, now 15 miles down the road, maybe 20 for the next one. So we're having to develop a whole new standard for this application, because we hadn't seen this before. We haven't had to try to meet this kind of complication. So this is our near future. We're working with this customer as to how we're going to manage this, but that will become a standard once we get all the bugs worked out.
I think about the industry where we've been in the past, the past 30, 50 years, the standards have been what they are. I mean, they get tweaked once in a while, just modified for a new product or something. But you're really writing the book on this, right? No, we've never done this before.
Writing it as we go, yes.
Well, that is a really forward-thinking challenge. And if you're not at this, if a utility's not at this level of integration with renewables, they're probably not seeing these issues yet. They may be thinking about it, but you're actually not only dealing with it, but you're helping to write the standards. That's awesome. That's really great. Appreciate, just from a societal standpoint, this is what we want to do, right? We want clean energy. So what can we do to make it practical? Some people say, well, just build it. Well, okay, but it's got to work, and you're making it work, which is that's just awesome. So, that's really a great forward-looking challenge. This is a fast-growing industry. We've got lots of challenges around the whole resiliency, the reliability. Affordability is a big topic right now. People are afraid with large loads coming in. Are we going to be able to afford that? There's just so many opportunities to serve and to really make a difference in meaningful work. If somebody wants to get into the industry, and in particular, your area of expertise, where would you recommend they start?
PNM.com.
Okay. Okay.
Look for job opportunities online. I recommend, I did not take a single power class when I was in college, but I really wished I had it. But I changed universities about halfway through, and so I missed out on getting a power class. There's only one university I've heard of that teaches a SCADA class. So if you're looking for a SCADA course of work, you're not going to find it. You're going to have to get that on the job training.
That's a good point.
I've got a really good team that my subject matter experts, my engineer fours on my controls and my telecommunications are both really good at teaching. But that's what you got to do. You got to have like an internal grow your own kind of engineer program sometimes. Talk to recruiters that come to your universities, get a feel for it, see if there's an area that piques your interest.
Right. There's just so many, there's data science, there's the actual design, the build out, the standards writing. I've been part of standards writing for decades, and that's a whole other area of network and building trust and building consensus, and that takes a totally different skill set, right? Than
it does.
The how to draw out the lines and actually design the infrastructure and specify the components, but also in the umbrella of a real need that we have as society. I think this generation's, more than maybe the previous, is really looking for work that's meaningful. And I think this is a great opportunity. And I love your story, because it's not, well, I went for, to be this kind of engineer, and I took this course and I aced the course and then I got the job. That wasn't the path. And I find that's actually pretty common. I think that's encouraging to others, that you don't have to. You have to have a curiosity and a desire to learn. And yes, helpful if you take some background courses, but like you said, you're probably not going to get the course in SCADA. Right.
And one thing I wanted to add was, if you're applying for jobs, and maybe especially for people right out of college, they're not going to have the skill set that you're going to look at the job description and you're not going to have any of those qualifications, but apply. If it's something that sounds interesting to you, apply. And sometimes I get resumes that aren't a good fit for my department, but I think, wow, I really like what this person has, what they've studied in college, their projects that they've done, that they've emphasized in their resumes. I think they would be a great person for this other department at PNM. So I do forward resumes once in a while when I see someone that stands out. Keep that in mind.
That's great. Well, referrals, referrals are so valuable, right?
Right.
And that's exactly, hopefully, what we're doing here too. We're building a community of experience and trust, and really appreciate your investment here in the Grid Knowledge podcast. And before we conclude, though, I'd like to give you an opportunity. Is there anything else that you'd like to share with our audience to something that you may have forgotten that you wanted to add, or maybe even some forward thinking words of wisdom, whatever you like?
I want to thank you for having me here today and talking about what we're doing, because we're really excited about all this here at PNM. And it's a big deal to be this involved in renewable energy when a lot of areas can't get as involved. We have the advantage of having so much sunshine here a year that other states don't get.
You're welcome. You're welcome. And I think it's fascinating, and appreciate you so much for sharing the complexity that you're seeing and how you're solving those problems. And when we were talking at IEEE, I immediately gravitated towards your conversation because it's not something I'm hearing, not at that level in the industry. And I really appreciate you sharing your knowledge with the Grid Knowledge podcast audience. And I look forward to working with you in the future. Maybe there'll be an opportunity for some industry panels or something, because this is something that the industry needs to know about. And I really appreciate you coming on today. Thanks,
Thank
Carol.
you. Thank you very much.